Today we will see assembler Pass1 and Pass2. Now we all know that assembler is a system software which takes as input program in assembly language and produces machine language code. So the assembly language program will be in the form of different opcodes and operands along with different labels. So the assemblers typically make 2 or more passes through a source program in order to resolve forward references in a program. Now what is a forward reference? It is defined as type of instruction in the code segment that is referencing the label of an instruction, but the assembler has not yet encountered the definition of that instruction. That means in the source program there are several instructions of the form label, opcode and operands, and suppose if the assembler is encountering a label but it is defined later in the program, such a type of reference is known as forward reference. Okay, so if the assembler is using only single pass to convert the source program to machine code, then it cannot handle all the forward references together. So in order to resolve this problem, the assembler usually make 2 passes or 2 or more passes through a source program to produce a complete machine language or the machine code. Now what are the functions of Pass1? So the functions of Pass1 are to assign addresses to all statements in the program, save the addresses assigned to all labels for use in Pass2, perform some processing of assembler directives. So we know that assembler directives are instructions given to assembler to do certain kind of processing and they are not converted to machine code. So the assembler will be reading the entire source program and it will be constructing a data structure known as simple table consisting of different names and labels along with their addresses used in the program. So this can be used by Pass2. So the Pass1 actually determines the amount of code to be generated for each instruction. So the output of the Pass1 will be an intermediate code along with the simple table. So suppose if the input is like this, then we can see that already told before it will be in the form of label, opcode, operand. So suppose these set of instructions are there in your input, then you can see here these are in the form of mnemonics or opcode. So corresponding to each opcode there will be a mnemonic value, and you can see here in the instruction LDA 5, this 5 is actually a label but it is defined later in the program. So 5 is a type of forward reference. Okay. Now similarly this RESW, that is an assembler directive, that is reserved word. Okay, so I just showed what is a forward reference and also an assembler directive. So the input will be like this, we will be seeing in detail later. Now we will see the program for Pass1. So here we are using file, that is file operations for performing Pass1. So we require actually 4 files and 2 among them are input files, and here we have the file fp1, file pointer for opening the file, that is input.txt, which contains the source program. Similarly, we are also giving the opcode for each of the mnemonics. So that is given by optab.txt and that file pointer is represented as fp4. So these two fp1 and fp4 are the input file pointers, and the output, as told before, it will be an intermediate text that is represented by fp3. So it should be opened in write mode because we need to write the intermediate instructions into this file. Similarly, we are also constructing a simple table which is represented as sim.txt, that is also opened in write mode. So these two input files can be opened in read mode because we are not making any changes. We are just only reading line by line from the file. So we have defined these file pointers. Similarly, we require the arrays for opcode representing opcode, mnemonic, then operand, label and code. Then the location counter, we know it contains the address of the next instruction to be executed. That is location counter. Each time it will be updated with the address of the instruction. So the start variable is initialized to 0, that is indicated, that is for representing the starting address, and for finding the length of the program we are using a variable length. Now just see the input. This input should be always in the form of label, opcode, operand. So this much portion will be the input which you are writing in a file. Already that file is there, that is given as the input, and you are opening this file. So the first step is to read the first line of this file. So for that we need to use fscanf. So fscanf fp1, that is from the input text we are reading the in line in the format label, opcode, operand. Okay. Now next we will see whether the opcode portion is start. So usually the first line of the source program will be containing the starting address along with the start assembler directive. Okay, so we need to check whether the opcode start equal to 0, whether the starting address is 0 or some other value. So 0, the equal to 0 means whether that is start, that means whether this opcode is matching, whether it is start, then we need to consider the address given by the start assembler directive, and that is taken as the location counter initial value. So here we can see in this program the opcode is start, and that is actually matching. So we will be entering into this if statement, this is true, and since this operand value is a character, it should be converted to integer. So for that we are using a function ASCII to integer a to I of operand. So that is stored in start. So here this 1000 value will be stored in the start variable. Okay. So in else case, suppose if this condition is false, then the location counter is initialized as 0, that means 0 is taken as a starting address. So if this is okay, then we can actually print the first line. We are printing the first line of the source program as such in the intermediate file. So you print fp3 represents the intermediate text, label, opcode, operand. So the intermediate text will be having copy start 1000, the first line of the source program as such. So first line should be directly copied into the intermediate text. Okay. Now before going to the next explanation, you can see this op tab is also the input given. So we have certain mnemonics, mnemonic code for this particular mnemonic. So LDA you can see 00, STA 0C, LDCH 50, STCH 54. So for the sake of program doing, you have to give this end also along with this opcodes as a last line of this op tab. Okay, so the end should be also given. So we are actually checking by using this end whether it has reached the end of this file, that is op tab. Okay, so these all are the mnemonics which is used in this program. So we are giving here in the optab.txt. So these two should be given as the input. Now, so we have reached here, so we have printed that. After that you need to read the next line of the source program. So again you are reading fscanf fp1 label opcode operand. So you have read this statement, that is star LDA 5. Okay, so this line you have actually read. this scope LDA 5 you have actually read, this LDA star star LDA 5. Okay, then you can see this it will be coming after this, and here you will be coming to while loop. So this is actually the main while loop. You're checking whether the opcode value sent. So here also you can see in the input file the last statement should be star star n star. Star star n means only in the opcode portion it is sent. So wherever there is no value in the label an operand, we are just giving a symbol star star. Okay, so we are just checking whether it is star star or not. So we are just simply giving, instead of star star you can use any other symbol. So here we are just giving star star. So the last statement should be star star end star star. So we are checking till this end. So the main while loop goes till end. So while string compare this opcode value whether it is end. Not equal to 0 means it has not reached end. So you need to write the location counter value to FP3. This FP3 represents the intermediate file. So first you have already written this label opcode operand. After that you need to write the address into the file FP3. So here you can see your intermediate file copy start 1000 already written. After that write this 1000 value, that is a location counter value. This is written here. So 1000 is actually written to the next line. Okay, then after that you are checking whether this label value is star star. That means whether there is a value in the label. If there is no value, that means the label will be star star. Okay, so in case of label, if it label is there, then that should be written along with the location counter value to the symbol table. So here in the first line, second line, you can see there is no label here. So that means what? The star star, it is true. So this if condition is false. Okay, so we will be coming to this statement fscanf fp4. That means you need to check the mnemonic code. So you are reading the first code along with the mnemonic from the op tab. So you read fp4. That means you can read this LDA 00. First LDA, that is mnemonic, is read with the opcode value, and you are checking whether this code you have read that has reached till end or not. So if it is reached end means you have searched the complete op tab, otherwise you need to continue in this while loop. So you are checking whether this code is matching with the opcode. What is this opcode? This opcode is this opcode value of the input text. So you are checking whether these opcode values are matching with this op tab. So simply if there is no label and if this opcode is matching with the opcode in any of the opcode in op tab, then you can just increment the location counter by 3. So normally we assume that each of the instruction is 3 bytes. So we are incrementing for each instruction. In normal case we are incrementing location counter by 3. So here you can see this LDA is matching with this LDA. So there is it is a valid opcode. So you need to increment the value of the location counter by 3. So location counter is incremented by 3 if this opcode is matching. Okay, so break and you can read the next new code STA. Again you can increment the location counter equal to it is incremented by location counter equal to 3. So that means you are checking all opcodes whether it is matching with any of the code. Okay, so the location counter value will be this code is n not equal to 0. So it will be breaking means one opcode is matching means it can actually break from this entire value. So it will be coming here. You are checking whether the opcode value is word, RESW, RESB, then byte, constant. Okay, so these are the values to be checked for the opcode. So in this case LDA, it is not matching any of this case. this opcode is matching, so you have incremented the location counter by 3. That means location counter was 1000 and is incremented by 1003, and it is coming here and is not matching any of the conditions. So you can just print the label opcode operand as such into the, or you can write the label opcode operand as such into the intermediate file. So you can see the next line after 1000, the star LDA 5, because label it is star and LDA is opcode and this is operand. So it will be written like this into the intermediate text. So you get the second line of the intermediate text. Okay. So after that, you can see you are reading the next line of the input text, label opcode operand. So next line means you will be reading now this STA num1. Okay. So the same process is repeated. Here you are checking whether this opcode is n. It is not n. So again the location counter is printed. So the location counter, now the values 1003. So that is printed in the intermediate text. Okay. Then after that, it is coming here. String compare. Again this condition is false. So you are reading the code and mnemonic and you are checking whether it is matching. So here you can see the second instruction is STA. So it is matching here STA 0C. So STA 0C means location counter is incremented by 3. That means it will become 1006. Then this all these conditions are actually false, and you can see that the label opcode operand can be printed as such into the intermediate text. So star STA num1. Okay. So for the next case also the same condition is repeated, that is 1006. Location counter values incremented by 1006 values printed. Then after that this line will be printed. Then after that again the location counter values incremented by 1009. Then this value is printed. So from the input file we have actually read till these, that is LDCH and STCH. For all these the intermediate text is generated. Okay. Now for the next case you can see it is num1 resw2. So in this case you can see there is a label instead of star. So in that case you can see the condition, this one, the star not equal to 0, that will be actually true. So you need to print what? You need to write the label along with the location counter into the simple table. So here the label is num1 and the location counter value will be this value, that is 1012. Already the location counter will be this 1012. So the num1 along with the 1012 is written into the sim tab. Okay. After that the same process is repeated, that is here you can see you are comparing this here this fscanf fp4 code mnemonic. Okay, so here this code is not matching with any of these cases because it is an assembler directive along with this num1. So here you can see resw is an assembler directive. So these conditions it is not true, so it is coming after this while loop and it is comparing whether the opcode is word. These opcodes are not matching, so it is comparing whether the opcode is word, resw, resb or byte. So in this case it is resw. So if it is resw, what you have to do? This resw means we need to multiply 3 with the operand value. That means since operand is a character, first you convert this into integer by using ASCII to integer and multiply with 3, and that value is added to location counter. So location counter equal to location counter plus that value, since it is resw word. Okay, so one word is actually 3 byte, so we are multiplying with 3. So we can see the location counter value now becomes 1012, so it plus this or value of operand is 2, so 2 into 3 6, so 1012 plus 6 1018, so that is the location counter value. Okay, so that is a location counter value, and after this the next statement is read coming to this line, that is fprintf. It is printed and it is scanning the next line of the input file. So next line means it will be 5 word 5. Okay, so here also there is a label 5. So whenever it is seeing a label, we can see whenever this label is not star star, you need to write the label along with the location counter value into the symbol table. So here we can see the label is 5 and the location counter value is 1018. So 5 along with 1018 is written to the sim tab. Okay, then after that we can see this line 5 word 5 is as is written to the intermediate text. Okay, then the next line is processed, that is num2, sorry 5, the 5 word 5 is processed. Okay, this 5 word 5 is processed. Okay, when 5 word 5 is processed, we can see that this 5 is added to the symbol table and along with the address, that is 1018. Okay, but here you can see the label opcode value is word. Okay, so since it is word, we can see what you have to do when you compare. It will be coming here, that is word. Word means simply we just increment by this 3. Okay, so this one word, okay, that is 3 bytes, so we just increment the value of location counter by 3. So location counter becomes previously it was 1018 plus 3 is 1021, so that is a location counter value. After that we will be writing this 5 word 5 into the intermediate text. Okay, the next line of the input text will be num2 byte x f1. So here you can see the label portion, it is num2. So again here it is coming to this condition, it is not star star, so you need to write the num2 along with the location counter value into the simple table. So here you can see this num2, that is 1021, that is the location counter values written to the simple table. Okay, now it has processes num2, and when it checks this opcode, it is byte. So in the case of byte, what is the condition? There are two cases for byte. Okay, it is byte constant. It can be hexadecimal constant represented by x, or it can be a character constant represented by c. So here you can see this operand is stored in an operand array. So you are checking whether the first element of the operand is x or the first element of the operand is c. So according to that you have to change the condition. Okay, so just see this. If we have num2 byte xf1, this x represent actually a byte constant, that is hexadecimal constant. So in this case of hexadecimal constant, always this value represented 1 byte. That means this f represents a half byte. So this is 1 byte. So we are just incrementing the location counter by 1 if it is a hexadecimal constant. Okay, so we are storing this operand value in an operand array, and we are checking whether this operand of 0 is x. If it is x, then increment the location counter by this length, that will be always 1, so it is incremented by 1. So that is shown in this code as operand of 0 equal to x, that means location counter is incremented by 1. The next case is operand of 0 equal to c. So suppose if this instead of x it is c, that means operand of 0 equal to c, it is a character constant. Then this length of this string should be found. That means operand should be found. Okay, so operand means this is a complete operand value, and it all consists of C, 2 single quotes, and EOF. Okay, so we need to find the length of this value, that is EOF, and we need to add that value to this location counter. Okay, so in order to find this length of this EOF, we need to find this length, string length, that is string length of this operand. So string length of operand, that means we get the entire string length of this minus 3. What is this 3? This 3 represents these 3 values, C and 2 single quotes. So C along with these 2 characters, there are 3 characters. Okay, so that should be subtracted from the length of the operand, and the location counter should be incremented. Location counter plus C equal to, that means location counter equal to location counter plus the string length of operand minus 3. So in this case it will be 3. Okay, so in our program there is only x constant, but if C constant is used, you need to give the condition like this: location counter will be incremented by string length of operand minus 3. That means find the entire string length of the operand and subtract 3 from this. 3 represents the length of these 3 characters, that is C and 2 single quotes. So in the program you can see, if it is operand of 0 equal to C, then location counter is incremented by string length of operand minus 3. Okay, so these are the cases of different opcodes. Okay, and finally you can see this C1 RESB1, that is reserve byte. Okay, so this in the case of num2 byte XF1, so you can see this F1 character. Here you can see the input is F1, so F1 is X. Since it is X, it is incremented by 1, so you can see the location counter value will be 1022. After that, this C1 is written here, and this C1 along with this 1022 is written to the simple table, and you can see the last instruction will be C1 RESB1. So that C1 along with this 1022 is written to the simple table. Now this RESB is the opcode portion. So if it is RESB, then one more case is there. If opcode is RESB, simply you need to add the byte value, the operand value, to the location counter, and it should be converted to ASCII to integer. So here, since the byte operand value is 1, you are just adding 1 to the location counter. So you will be getting the location counter value is 1023. So this is already written, and location counter is in 1023. And finally, you need to write these statement 1023 star star and star star to the intermediate. That is, this along with the location counter values finally written to the intermediate text. So that is shown in the code like this. That is, after checking all these conditions, for the last statement you need to add the location counter, label, opcode and operand to the intermediate text. Okay, and we also require the length of the program for Pass2. So here the length is found by subtracting the start value from the location counter. For example, here the start value is 1000 and location counter value, you can see it is 1023. The length of the program will be 1023 minus 1000. That is actually printed, and the length of the program will be getting as 23. This will be used in Pass2. And one more thing, here you can see after this label, opcode, operand, you can give a statement as, here this is not included in the program, you can give a statement as rewind, because rewind of FP4. So here you can include one statement, rewind FP4. FP4 actually represents a op tab. So this op tab you can see this file pointer will be at the end. So again, if you need to check the op tab, again the file pointer should be reset to the first position. So for that we have to use rewind. So here in this program I have actually missed that statement, so you can add this rewind statement, f rewind of FP4 here. Okay. So that's all. Thank you.